Hi dears, in this video we are going to discuss the exercise 13.1. Question number 5. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. So it is given maximum diameter of hemisphere equal to side of cubical block, that is equal to L, and that we take it as the diameter of hemisphere. So radius is dividing by 2, we get L by 2. To find the surface area of the remaining solid, we add the TSA of cubical block and the CSA of hemisphere and subtract the area of the base of hemisphere. So that gives us the answer. And TSA of cubical block is 6A square. Here the side is L. So it is 6L square. And CSA of hemisphere is 2 pi r square and area of base is pi r square. So 2 pi r square minus pi r square is plus pi r square. Substitute the values and find the answer. That is 6 into L as it is, there is no change in this. Pi into r is L by 2 the whole square. So it will be 6 L square plus pi L square by 4. If you want to simplify, you can take L square as common. 6 plus pi by 4. Question number 6. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends, and the length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Find its surface area. So let us write the given data first of all. The total length is 14 mm, diameter is 5 mm, divided by 2, find the radius, that is 2.5. So the total length is 14 mm. To find the cylindrical part height, we need to subtract 14 and the radius of the hemisphere. So here it is 2.5, here it is 2.5. 5 mm, totally we get 9 mm. Surface area of the capsule is, only this part of cylinder is required, that is CSA of cylinder. Similarly, the CSA of hemispherical part, since both are same, we can write into 2 into CSA of hemisphere. Okay, the formula will be CSA of cylindrical part is 2 pi RH, and here it is 2 into 2 pi r square. We can take 2 pi r as common, we get h plus 2 pi r we have taken, so 1 r and 2 is there. Substitute the value, 2 into 22 by 7 into r is 2.5, or you can take it as 5 by 2. H is cylindrical part, that is 9. 2 into r, I am here using it as 5 by 2, or you can use the decimal 2.5. 2 and 2 we can cancel, it is 110 by 7 into, here also 2 and 2 gets cancelled, 9 plus 5 it is 14, 7 ones are 7, 7 twos are 14, so it is 220 millimeter square. Question number 7. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical parts are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of 500 per meter square. Note that the base of the tent will not be covered with the canvas. For this canvas, only the upper part of the cone is required. That is, only the curved surface part of the cone is required. Same way for cylinder, only the curved surface part is required. The top and the bottom is not required for the tent. Let us write the given data for cylinder and cone. So the area of canvas used is CSA of cone and CSA of cylinder. Let's substitute the formula. CSA of cone is pi RL and CSA of cylinder is 2 pi RH. We can take pi r as common, remaining will be L plus 2h. Substitute the values, 22 by 7, radius is 2 into, slant height is 2.8, height is 2.1, get 44 meter square, and the cost of 1 meter canvas is 500, so cost of 44 meter square is 44 into 500, that is rupees 22,000. Question number 8. From a solid cylinder whose height is 2.4 cm and diameter 1.4 cm, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter. So we have the same height. If you see the diagram, we have the same height and the radius for both cone and the cylinder. Write the given data. The remaining, like when you take out, the remaining will be, it will look like this. It will be the CSA of the cone and the CSA of the cylinder and the base part. To find the slant height, as CSA is required, substitute the values. L is square root of r square plus h square, that is 0.7 the whole square plus 2.4 the whole square. It is 2.5 meter. Now, the TSA of remaining solid will be CSA of cylinder plus CSA of cone plus the base, area of base. CSA of cylinder is 2 pi r h, cone pi r l, base pi r square. If you see pi r is common, so we can take pi r out. It will be 2h l r. Substitute the values. 22 by 7. R, I am taking it as 7 by 10 instead of decimal. If you want, you can use it as decimal. And 2.4 as 24 by 10 plus slant height is 2.5, that I am taking it as 25 by 10. R again as 7 by 10. 7 and 7 gets cancelled. We can cancel here 5 times and 11 times. So it is 11 by 5. 2 into 24. If you see the denominators are same, I am adding the numerators. 48, 25, 7. 11 into 1.6. 17.60 centimeter square. Question number 9. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder as shown in the figure. If the height of the cylinder is 10 cm and its base is of radius 3.5 cm, find the TSA of the article. Write the given data and if they have scooped out this hemisphere from both the ends, the article will be looking like this. That means the cylindrical part, the CSA of the cylindrical part and the CSA of the hemisphere. That is only required here. Let us write. The TSA of article is CSA of cylinder and CSA of hemisphere. We have two hemispheres, so we write it as 2 into CSA of hemisphere. And CSA of cylinder is 2 pi RH and CSA of hemisphere is 2 pi r square into 2, it is 4 pi r square. We can take 2 pi r as common, it will be h plus 2r. Substitute the values. 2 into 22 by 7 into h is 10, r is 3.5, so 2 into 3.5. Into 3.5. 44 and 7 we can cancel, it is 0.5. So 44 into 0.5 and here it is 10 plus 7, 22 into 70. Answer is 374 centimeter square.